Today I will discuss about water cycle algorithm. This is one more bio-inspired or nature-inspired optimization algorithm which has very recently been proposed and now widely popular and widely utilized to solve optimization problem with the help of meta-heuristic. This also falls under meta-heuristic algorithms. Okay, the optimization problem is just like this. We have to minimize this function. This is a minimization problem. As you know, there are three different types of optimization problems. One is maximization, one is minimization, another one is to achieve a specific target. Now, minimization problem is also known as cost function, or to be more precise, the objective equation used for minimization problem is also referred as cost function. And the objective equation which is used for a maximization problem, it is known as profit function. And the target-based optimization problem is known as target function. So presently we will consider this objective equation to be the cost function, as our goal is to minimize this equation, y is equal to x squared. And we have assigned this equation A, and constraint is like this: x can be varied between 0 to 1, but it cannot take the value of 0 to 1. And x will always take real numbered values, no imaginary values are permitted. Now, this specific algorithm, water cycle algorithm, mimics the water cycle that is observed in the nature. As you can see, this is a schematic diagram of water cycle or hydrologic cycle. Due to the heat from sun, water evaporates, it gets condensed in the atmosphere, and cloud is formed, and cloud creates precipitation. This precipitation form surface runoff, which comes into the stream, or surface runoff forms stream. Now this, you see, the surface runoff is forming stream, and this stream merges with the river, and the river merges with sea. So this is what more or less is the water cycle. Yes, so these are the equations that we are discussing about, or will discuss later on. So this is equation number 1 to initialize the total population. As I will discuss later on we will generate 10 number of random values of x. Here they are saying this n pop is the total number of population generated, n pop, and this 1 is your dimension of the design variable. That means here we can use up to d number of design variable. So they are indicating this d in subscript and the population in the superscript. That is all in it. So as I will discuss later on that how you can classify x into C, into rivers and into stream. Now equation 2, let us come into equation 2, maximum number of streams that will be added to river. This is assumed by this equation 2. What is its role? You can understand in the next slide. But for now, you remember that this n is total number of stream at iteration number n. You will take the round off value. This is the value of cost function at iteration n. This is the value of cost function at NSR plus 1. That means it is the optimal cost function divided by summation of all these constants C. C is actually this one. Okay, and this C can take any value within 1 to 2. And you have to sum all the values of C for all the iteration up to that iteration. Remember that. Okay, so there will be n number of C if you generated n number of x values which can be added to river. Okay, so this is a condition that you must check before you can generate a new excess or new population, or often we say it as new position. But for now you refer it as new population. Okay. So how to generate new population based on equation 3? As you see, I will discuss how you can classify a population or a value of x into C, into river or into stream. But for now, let me give a summary that if you generate 10 number of x's and you put into your equation y is equal to x square, that is, this is the objective equation, this is the minimization problem, so this is referred as cost function. Okay, and cost function is always minimized, not maximized. It is very common. So the value of x for which y is minimum will be the most optimal value of objective equation. So that value of x is referred to as C, and followed by the values of x's which will have a value of y which is less optimal to the minimum value of y, but more optimal than the remaining values of y. So if this is the minimum value of y, or this is the x for which we have got the minimum value of y, then this river, the value of x's for which we will get the second minimum, third minimum and fourth minimum value of y will be classified as river. And I am assuming there is 3 number of rivers. Number of rivers will be assumed by the user. But total number of streams that can be feasible or valid, which can be added to form rivers, can be determined or has to be determined by this equation. Okay, round off value of cost function at iteration n minus cost function of iteration, or the optimal cost function, divided by total value of C into n stream, n number of into n stream means total number of population that you have generated. Okay, so as you have generated 10, so you will use 10 here, and so. And now let us come to this thing, equation 3, how to form the new population for generating stream values, the values of x which can be classified as stream, here the values are generated with the help of equation, not by verifying it after putting into y. It is before that. It is not doing that. First time we have to do that, but second time x stream is calculated by this equation. Okay. So how the equation is? The x stream value at equation t, that means the current iteration, plus random function. This is very popular thing. Random function means 0 to 1 but not equals to 0, not equals to 1. Any value in between 0 to 1 which is randomly generated. Multiplied by c, I have said what is c. C is constant and varies between 1 to 2. So often users take this c as 2. And then the values of x for which y is most optimal, the c, you deduct the stream values from C to get the new values of stream. Okay, that means xc, if 0. For x equal to 0.12, y is minimum, the 0.12 minus x stream. That means, sorry, this can be 0.24, 0.25, anything. Okay, if there are 6 values which are clubbed under stream, then you can get 6 number of new values of x stream. If there are 8 number of x stream, then you can get 8 number of x stream. This is determined by this equation, of course. Okay. So what happens in our case, we have taken 10 number of x values. 1 is C, 3 is river, and remaining 6 is stream. So first check whether this satisfied this equation. If it is satisfied, then you use an equation known as equation 4. So that equation will give that whether the x's are from the visible domain or not. And then you use this equation to generate 6 values of new stream. And then you see this same thing can be done from the reverse also. And then you can generate the values of river by using this xc minus x river. So you can generate 3 new values of river and 1 value of 6 values of x stream, either by this way or by this way, any way that you feel comfortable. So after then you get 10 number of population, new population again, and now you'll say where is the C? You'll take the so what I can suggest is that however the C, yes, correct. So this extreme, as there is only one C, but there are 6 different streams. There is 3 rivers, so there are 6 different streams here also. So actually what you can do is you can generate from here 6 values and from here 3 into 6 values, correct? From here, if you can observe 6 value of stream, 6 different values of x stream we already have. And here we already have 6 stream, but there are 3 different values of rivers also. So 6 into 3 is 18. So 18 plus 6, 24. And in addition to that, you can generate also 3 values of x rivers, right? So 3 values of x river, 18 values of x stream, and the original optimal value of xc remains as it is. It is not generated, a new value of x is not created by these formulas. So again, with the help of this 21 number of new values, we put this on that equation y is equal to x square and generate new values of y. Now if within these 18 values any y is less than this y, that means the cy, right? The values of x for which y was the minimum in the first iteration or the current iteration, that will be compared with all the y's of this 21 x's that we have generated from this formula, correct? Now within this 21 values, if any y is less than the earlier y, then we will replace the c value with that new y, correct or wrong? Okay, and if that is that new optimal value of y, if come from a value of stream, x stream, then this new x stream can be directly added to C. That means that x stream can be exchanged with the value of x as river. So don't go into this river and stream jargons. Just remember, if the y value, if we get a new optimal value of y which is less than the current value of y, optimal y, then you can replace it. Then the new x from either the x stream or x river that we have generated here can take the position of new xc, and the earlier xc will then convert into x river according to its position. Okay. Correct? So again a ranking will be done. This time there is 22 number of values are there. So 22 ranks will be given according to the rank. First value, the minimum value of y, the value of x for which we have the minimum value of y, that will be that x value will be designated at C, followed by 3 values of x as rivers and remaining as stream. And here exchanges can occur. If we find that some value of stream, some x's which are classified as stream is giving a better result of y, then it can be exchanged with a value of x which was earlier classified as river. But now this new value of x can exchange it, or it can exchange the c also. There is no restriction in it. Only thing is that it must satisfy this equation, total number of stream, and those x's must be collected from the search space indicated by Dmax. And what is Dmax? Dmax is x is the value of x which has generated minimum value of y in the current iteration minus the value of x which generated the next best value of y. So these two differences, as there are 3, so you have to check 3 times because river is 3, note down. So xc minus x river, that is why this j is given as script. J is indicating the river number. So x river 1, x river 2, x river 3. And this Dmax is generated from this one. First, it is a random value which you indicate which will be less than 0.1 at the first iteration. This Dmax will be a random value which will be less than 0.1. Okay? But after then you have to use this to get the new value of D. Okay, and then you use this xc minus x like that for that next iteration, not for that current iteration. So what is this? The new value of D is, it is equals to D max T, that means D max of the current iteration minus D max of current iteration divided by maximum number of iteration you are planning to conduct. So if you are planning to conduct 100, then accordingly it will change. If you are trying to conduct 1000, accordingly it will change. Note down, maximum iteration is in the denominator. Okay, so you understood what? More the number of iteration, maximum iteration, lesser change will be in new value of d max. Because this term will then become very negligible, so this term will sustain. Correct? So if this term sustains, then d max t plus 1 will be nearly equal to t max at t. Okay, so note it down correctly. So this is the flow chart of water cycle algorithm. The first step is to initialize with a set of random population. Say for example, we have to generate certain number of x values. Okay, that means the objective equation is like this: y is equal to x squared. So we have to generate different values of x and note this is the value of y. And as this is a minimization problem, the lesser the value of y, more optimal the equation is. So what we will do is we will generate the values of x at the first step of this algorithm. Say for example, let us generate 10 number of x value randomly. And as x can take a value between 0 to 1 and not equals to 0 or equals to 1. So we can take any values like 0 0.12, 0 0.20, 0 0.41, any number of 10 values. Okay, so 0 0.5, 0 0.6, then 0 0.7, how many? 1, 2, 3, 4, 5, 6, 0 0.75, randomly, there is no pattern. 0 0.81, 0 0.9, like this. So I have taken 6, 8, 9, 10. So 10 number of values I have taken. And this 10 number of values I will now put into my objective equation, or I will put it into my cost function. I have already said why it is cost function and not a profit function. So I have already explained that why it is a cost function and not a profit function. As we always try to minimize cost and maximize profit. So when an objective equation is for minimization, we refer to it as cost function. And when it is for maximization, we refer to it as profit function. So I have generated 10 random values, and one by one I will put them into this equation, and a new y value will be generated. So for 10 x's, 10 y will be there. Now I will arrange these y values into ascending order. That means the smallest y will be in the top and the largest y will be in the last. So the smallest y will have the best rank and the largest or biggest y will have the worst rank, because our goal is to minimize the equation. So minimum the value of y, better is the result. Correct. So we will arrange this like this. So the minimum value of y will get the rank 1, the best value, and the maximum value of y will get the last rank, that is 10. So the x for which y will be minimum, that x will be referred as C. You see, this is the next. First step is initialization. Second step is put in objective function, analyze. What I will analyze? For which value of x, y is minimum. So y is minimum means y is most optimal. So that value of x will be the C, because C is the ultimate destination of water in a water cycle. So that is why C is the place where the most optimal position of water. So as the value for x for which y is minimum, that will be the most optimal value. So the value of x at which y is most optimal, that x will be referred as C. And then the second, third and fourth y, or the value of x for which y has a rank of second, third and fourth, those will be referred to as river. This is the second most optimal position of our water. And remaining, this is 3 and this is 1/4, and remaining 6 values of x will be referred as, yes, it will be referred as stream. Now number of rivers, please note down, will be the user defined. I have used here 3, you can use 4, or someone else can use 5. That depends upon the user. But please note it down that more the number of rivers, more complex will be the algorithm, more time it will take. But yes, more optimal values can be expected. So, as I have said, remaining values of x will be considered as stream. Now the next step. The next step, what we'll do, we'll check whether these values of x that satisfied equation 2. Now what is equation 2? Equation 2 indicates the total number of x that can be generated as stream. Although number of x that can be referred as river is user defined, you and I who are using this algorithm will determine how many number of rivers we can use. And C will always be 1 because position of optimal y will always be 1. So what is the number of stream? So that should be generated by this equation 2. So I will later on come into equation 2. Let me finish first. Now, if it satisfies equation 2, then our next question will be check whether equation 4 is satisfied or not. Now, what is equation 4? Equation 4 will give you the maximum distance within which we have to take the values of x. Beyond this distance, the domain will be infeasible. So if this is your circle, this is your feasibility domain or domain of feasibility, or where you can take valid values of x. So that means if you remember the problem, x can take this one 0 to 1, not equal to 0 or less than 0, not equals to 1 or more than 1, only in between. So this to this, if this is your x equal to 0 and this indicates the 1, then the distance d max will give that distance within which you can collect values of x. We also refer it as domain of feasibility or region of feasibility. This is extremely important. They mimic it like evaporation, because as I have shown you in that hydrologic cycle image, Evaporation has an impact on water cycle. So evaporation evaporates water from the surface water bodies, and then it will get condensed in the atmosphere, forms cloud, and this cloud creates landfalls into precipitation, and precipitation actually creates new water droplets, and in optimization term, this new thing is similar to the mutation of genetic algorithm, which helps to avoid local minima or overcome local minima, a very common problem where metaheuristics always get stuck. So this local minima can be avoided by checking this condition, equation 4. I will come into equation 4 later on. But for now, let us take that TOXs must satisfy equation 2 and equation 4. What is equation 2? Total number of streams. What is equation 4? Maximum distance from where you can collect X. Actually, this distance also indicates the distance from which or within which, if any droplet of water is evaporated, it has an impact on both the stream, rivers and sea. Because after precipitation, it creates stream. Now all the stream merges into rivers, and all the rivers merges into sea. And please note it down, C is the best value of y, that means a value of x for which y is optimal, followed by the values of x in river, then followed by the values of x in stream, in the order of optimality. So yes, if this is also yes, then we will go to this part, generate new T. Remember this D max that you are checking at this step, equation 4, this one. These D max also get changed at every iteration and infuse or imbibes adaptability in this algorithm. So once this new D is generated, it follows equation 5 to give you the value of new T. So after that, you generate the new population with the help of equation 3. So in equation 3, I have given how you can create the new population. Okay, and then new population is fed into the objective function and the entire process is repeated. And what happens if any of these two conditions, this one and this one, is violated or not satisfied? If any one of them is not satisfied, we again go to step 1. Initialize set of population, randomly generated population, and then we repeat this. So you can understand the logic behind these two conditions. These two conditions are extremely important because it prevents the algorithm from falling into local minima. And it's also prevent the algorithm to generate infeasible values of x or design value. Here x is your design value, correct? So to prevent these infeasible values of x and to prevent falling of algorithm into local minima, these two equations must be checked. So these two equations, another equation, I must say this as condition. Correct? So this is more or less the water cycle algorithm. It has very simple algorithm with 3 steps. First step, randomly generate population, put it into your objective function and analyze the value at which, the value of x at which y is minimum will be C, followed by river and then followed by stream. But total number of although the river number or total number of river is user defined, but total number of stream is condition defined. You must check that condition. And then you must also check the Dmax. All your x must come within Dmax. Okay, from the domain indicated by or limited by Dmax. And then you have to repeat generate new position of population, what the value of x, as well as before that you have to generate a new T max. Okay, so this is more or less what is our water cycle algorithm is. In the next step, what I will do is I will demonstrate it, or I will explain the equations. And this is the graphical representation of the water cycle algorithm. You see from stream going to, this is a new position, correct, new position, those new formulas. This is margin to river, and this is the river network. This one is the river network. These are streams. Black circles are the old stream for the values of x at current iteration. These are new stream, values of x at new iteration. This will merge into the rivers. Also, this is the old one and this is the new one. And ultimately, all will fall into C. You see one thing, C doesn't have new position. Okay. So new position can be of river, can be of stream, but C will be one. And yes, it can be exchanged, but not new position is there. Okay, so with this, I will end this presentation. So in short or in summary, what can be said? Very simple algorithm and very useful one also. The summary said, initiate population randomly. Population means value of x. So I am assuming the rivers to be 3, C will be 1, and remaining 6 stream. Okay. So put it into the objective equation, get y, values of y, rank the values of y in the ascending order, where the lowest value of y will get the best rank, and the highest value of y will get the worst rank, because my problem is minimization. I am reducing the cost function. And then what we'll do, the best y, the value of x for which y is best, that value of x will be the C, followed by 3 rivers according to the rank 2, 3, 4 will be the river. This is x1 and then x2, x3, x4 will be the river, and from x5 to x10 will be the stream. Now what we have to do, before generating new values of x, what we will do is check 2 conditions. One is number of stream that we can take. We will check that whether this condition is satisfied. And another one is the distance of the feasibility domain with the help of Dmax. I already discussed all these things. So if these 2 conditions satisfies, we will try to generate the new position of x, rivers, and x stream. Right? And then we again generate the values of y. And if the minimum value of y can replace the existing minimum value of y, then a new C will be generated. Otherwise, it will again return back to the first iteration. That means it will again randomly generate population. And then they have to satisfy this check, this 2 and 4. And then a new position will be created. And then again put y, again so on. This is a circle. So this is in short is water cycle algorithm, and this algorithm is known for or popular as it takes only 3 steps to complete, and number of parameters are not much. Very few parameters to determine during your iteration step. And also due to the introduction of this Dmax to avoid local minima and this NS to avoid selecting more than desired or more than required number of population, that means the number of streams. So for these two advantages, many people prefer water cycle algorithm over the other metaheuristics. With this, I'll finish my presentation. Thanks for your patience hearing.